Hey guys, this is Mr. DeGrow. We're actually looking at page 15 right now. These are some of the prerequisites that you have to know to be able to do the notes in the next video. So we're just going to go over the special right triangle patterns. And the ones we have on this page, I'm actually going to write them a little bit different. Let's forget about this one for a minute. And we're going to talk about what type of triangle this is. So this is a 45, 45, 90 triangle. And I mean, I can tell you what they are, but the idea is in any 45, 45, 90 triangle, these are isosceles, they're the same. So I'm going to make this x, and we'll make this x. And we're going to forget that this is saying 1, and we're actually not even going to have that be 1 later on. So if these two are both x, what does the hypotenuse have to be? So we can use the Pythagorean theorem to find that. So that would be x squared plus x squared equals c squared. Now these are common, so we got 2x squared equals c squared. So what's my hypotenuse? Well, if I square root both sides, I get x root 2. So x root 2. Now these x's can be anything, so what we're going to use, I'm not going to make the hypotenuse 1, I'm actually going to make x just equal 1. So x could be any number I want to. If I let it be 1, then this side is 1, this side is 1, and this side is just root 2. Now, until we take the test, I'll put this on the sideboard, and this could be just notes. But when you draw your reference triangle, you need to know this before you can do anything else. So all 45, 45, 90 triangles follow this pattern. Now, I could do more with this, and if you go into the unit circle, they divide everything by root 2, and you get different relationships. You could have this be a 1 if we wanted to. Just a different x value, not x equals 1. But this is one we're going to use as a class. Now I'm going to do something very similar for the 30, 60, 90 triangle, except what I'm going to do is I'm going to make it a 60, 60, 60 triangle, which is an equilateral triangle. And that means I'm not going to let this be 1, I can't erase that, sorry. I'm going to let this be x, and then this would be 2x. Because if this side's x, and this is just continuing it out, this would be 60, this would be 60, it would be an equilateral triangle. So if this is x, this would also be x, meaning the whole thing's 2x. So this is x and this is 2x, let's find our b. So same thing, we got a 2x, sorry, that's our hypotenuse. So x squared plus b squared equals 2x squared. So b squared equals, sorry, a little slower, x squared plus b squared equals 4x squared. Subtract over the x squared, and we get b squared to be 3x squared. Square root it just like we did before. We get b to be root 3x. And I'm going to do the same thing. We'll let x equal 1. So everywhere I see x, I'm going to make b a 1. So this side I'm not going to have be 1. I'm going to have this actually be 2. So it's 2 times 1. So no 1, but a 2. And this side is 1. And then this side would be b, which is root 3 times 1. So we talk about opposites. So here, the opposite of the 45, I'm going to be 1. Opposite of the other 45 is also 1. But the opposite of the 90 would be root 2. Over here, if I say what's opposite 60, the answer I'm looking for is root 3. What's opposite 30, it's 1. What's opposite 90, it's 2. Now the other half of this triangle doesn't really exist. So this is our relationship. So it doesn't have to be in that form. I mean, I could draw it any which way I want to. So if I have a 30-degree angle here, what I would draw in, and what we're going to eventually do is we're going to make this be on an axis. Maybe that's really not 30. Maybe we're looking at 150 degrees. Where this is 150, my reference angle would be 30. So the triangle that I would draw, opposite 30 would be 1. So opposite 30 is 1. Opposite 60 would be root 3, and opposite 90 would be 2. Now, a couple things that are different if I'm going to draw this on an axis. This is not really a triangle. This just represents a triangle. We're using this triangle really to represent this angle more than anything else. And the goal, which we'll talk about in the other video, is tell me what the sine of 150 is. And to do that, you draw this reference triangle like we did. You put in your sides, and when you talk about a real triangle, you can't have negative sides to a real triangle. but there's no like physical triangle in this whatsoever. So when I put signs on this, it's not to be weird, and it doesn't really have a side length. So the signs that I'm proposing is that negative root 3, so this should be a negative, and these should both be positive. Now, hypotenuse is always just the distance from the center, so that's always just a positive distance. And the Pythagorean theorem always have to add up to some number squared. However, we want to think of this going left root 3 and up 1. So since it's going left root 3, it's a negative root 3. So not wanting to just give away what the next video is, the answer to this question would be, well, we use this reference triangle here, sine is opposite over hypotenuse, so this should equal 1/2. And for this particular problem, you feel free to type that in your calculator and see if you agree with me. Alright, so that's the basics. So you have to know what your 45-45-90 triangle looks like. You have to know what your 30-60-90 triangle looks like. You have to know how to find a reference angle, which is in our last set of notes. You do need to know SOHCAHTOA. Okay, so you have to know SOHCAHTOA. You have to know that cosecant is the flip of sine, and that secant is the flip of cosine, and cotangent is the flip of tangent. You put those together along with the next set of notes, and you should be able to find the sine of 150 on your own, with the cosine of 240, the tangent of negative 360. All right. So stop this video, watch the next one. A quick note about that: the very first problem, I forgot about this negative symbol, and if you watch it halfway through the second problem, I catch it and I fix it. But if you watch it, I'm aware that I made a mistake, and it does get fixed, but it'll look a little weird since we talked about this already.